Okay. Yokoso minasan. Irashaimase. Anyway, welcome everybody. Let's see. All right. So before we start, let's do some exercise. Yoga exercise. Okay, so you have to stretch your arms up. No. Always good to do yoga though, actually. I recommend it, even though I don't do it very often. Okay. But when I was your age, actually, I was crazy about yoga. I used to practice for 4 hours a day, but not anymore. Okay, anyway, so we have a class. So, I have to do the translation. Okay, let me do the translation. I don't know if anybody's using it, but I'll try it. So I will start the conversation and sign up and start the conversation. Okay, the code, conversation code at translator.microsoft.com is here, that, here, and that is at here. Okay, so I sent the code. So if anybody wants to join and see that lecture in a different language, you're welcome to try that out. Okay. And what else? I have to make is Dan here? Yeah, he's co-host. Okay, good. All right, Dan, Derek rather, could you send me the attendance sheet? I'm sorry, no, let me do it differently. Let me send you something. Let me send you something. Just send this message to our TA. I can figure out how to send them. Okay. All right, I did that. All right, let's look at something. Today we have to get our group assignments. And today we have to talk about
Professor, you're muted.
Okay, I have 3 monitors, maybe even 4 running, and maybe that's not a good idea. So my computer crashed, but I did order a new computer and it's coming on Monday, so maybe that will help. But anyway, let's continue. So as I was saying, we have the groups today, group assignments and data assignments. So we want to talk a little bit about the data first. So let me share a document with you first. Okay, so I will go to Manava. Let's see if I have that there already. If not, I'll just upload it. Here we go, I have it. Okay, so if you go to Manava, and if you look in the resources, I want to share my screen, sound. Okay. So if you go to Manava and you go to the resources, you will see this, dealing with data. So let's open that up. You don't have to open it up, but I just want to show you where it is. Okay, so this is a document that talks about how to deal with the data sets that you'll get. So some of you are going to get data sets that are just a single file and not so many rows of data. So in that case, you don't really have to worry about this stuff. But some of you will get data that comes in more than one file. And then you have to figure out what to do. And some of you might get data which has like millions of rows. And in that case, you also want to think about something to do, because you really don't want to try and build a model that with huge data, unless you have access to like big computers. You don't really want to do that. So in that case, what do you do? So that's what this document has links to how to do these, how to deal with these issues. These are all different, I think, YouTube videos. So let's just mention what they are. So if you have your data set, well, maybe I should also show you your data sets. I mean, a list of the data sets. Let me see if I can find that. Right. Okay. So here is a list of data sets. And we want to know like what to do if we have too many rows, what to do if there's more than one file. And you also, you have to think about, now a data set just is a bunch of columns and rows, or it might be several files with columns and rows. So the columns are the variables. So the question is, which variable are you going to try and predict? So among all the variables, all the columns, you have to choose one and say, I'm going to use the other columns to try and predict this one column. For example, last week we saw the data set, which was, let's see if I can find that. Let me go back and find that. That was, we had the golf data set, if you recall, last week. And Let me just bring that up here. Okay. Here. Let me just bring that up again. So we look at that data set, wherever it is, here. So this is a data set. It's columns, 1, 2, 3, 4, 5 columns. I just separated this column just for emphasis, but it's just normally right next to it. And rows, row, 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 row. So this is a data set. And there are 1, 2, 3, 4, 5 columns. So there's 5 variables: outlook, temperature, humidity, windy, play golf. So you have to decide which one you're going to try and predict. Now, here we were trying to predict whether people were going to play golf, but we could have just, instead, we might have said, oh, we're going to try and predict whether it was windy that day or not. And this would then be one of the input variables, and this would be the output variable. Or we could have said, oh, I'm going to try and predict whether it was humid that day, or if the temperature was whatever, hot, cool, or mild, or the outlook. So you could choose any of the however many variables there are as the output variable. Now, if you're working in a business, that's usually not what you would do, because usually in a business, they have a particular plan that they want, like they want to predict sales, or they want to predict what a given customer is going to buy. So what they're going to buy would be the output variable, and everything else would be the input variable. So you don't typically have a choice in terms of what you would predict. But here, in the abstract, you do have a choice. I mean, you could do any one of these, but sometimes there's an obvious choice. But anyway, you could do any of them. So you have to decide when you get your data set, which variable are you going to try and predict. So going back to here, these are all from Kaggle, that website called Kaggle, and there usually is some discussion, on the page for this one, and on the page for this one, and this one, and so on, about what's going on, and I don't know, just a discussion about the data. And usually they'll probably set, assume that, which variable is the output variable. So you can take a clue from that, but it's not a hard and fast rule. I mean, and they may not say it explicitly, actually. I mean, I think they do, but they may not. The discussions and the way this is presented in Kaggle is not uniform. It's not all the same. And so, I don't know, I guess anybody can throw up their data there, and then there's no rule about how you have to describe the data and so on. So it's not always uniform. So anyway, so you might have to decide which variable are you going to predict. Now, we talked about a little bit, I think, about numeric and non-numeric variables. Now, if we go back to this here, usually, you would think of temperature as a number, right? But here, they didn't write it that way. They didn't label it that way. They labeled it just as hot, mild, and cool, okay? So although normally temperature would be a number, it's conceivable that you wouldn't have it as a number. And that maybe I should just mention, how about if temperature was actually originally collected as numbers? So let's suppose it was the Celsius system of measuring temperature. So, like today, the temperature is probably about, 20? Temperature might be 20 today. So, maybe this day was 20, and this day was whatever, 18, and this day was 25, whatever. Each day had a different temperature. How did they get to this? I don't see numbers here. So what did they do? Is I can imagine that if, the people are really collecting data, they probably don't just collect it as hot or mild or cool. They might, but typically they would check the temperature outside and just write it down. So how do they get from what they just wrote down to something like this? Can anybody say that?
Professor, can I try to answer?
I can't hear it. Say it again.
Can I try to answer, Professor?
Yes.
So I think they set certain requirements. For example, if it's over 35 degrees, we will consider hot. Doesn't matter, it's 36 or 38, still it will be hot. And if it's, for example, less than 20 or 18, we will consider it cool. So it can be 10 degrees or 15 degrees, but as long as it's less than, for example, 18 or 20, it will be considered cool. So they have set like I don't know, upper and lower limits for each range.
Right. So they probably, exactly. So they probably would do something like this, right? They say, well, let's just show here. Let's say, so here's the temperature. I mean, it's not very mysterious, right? So there's the temperature scale here, the temperature axis, temp. Okay, and they'll just break this up. So they'll say if it's, whatever, let's say you said 20, put 20 here. So if it's 20, and then if it's, you said 35, but I'm going to say 30 because I think 30 is hot. So, if it's in between here and here, it's mild, and if it's less than here, it's cool, and if it's above here, it's hot. So it's obvious, right? So they just set some cutoffs, right? So basically, what we're doing is we are dividing the temperature. Is that wrong? Temperature axis into intervals. That's one way to say that, what he just said. We're dividing the temperature axis into intervals. So, you'll have the cool interval, which is like here. Right? And you'll have the whatever it was, moderate interval, which maybe is here. So that's like here. We have 3 intervals. And then we have the hot interval, which could be up here. Okay. So we just arbitrarily divided the entire set of numbers into just 3 intervals. Now, it doesn't have to be 3, right? We could have divided it into 4 or 5 or 10, and then we could have said like super cold, moderately cold, minimally cold, and so on. We could have just made up different labels. We could have divided it into 10. And so so let's just say that we are taking numbers, or we could say numeric data, and breaking it into intervals. Okay, so we took basically, the temperature scale is sort of infinite, right? Because you could have, the temperature today was 21, but it could have also been 21.1, or it could have been 21.12, or it could have been 21.1289, or it could have been this, right? We could go on forever and ever and ever and ever. So basically, this temperature scale is infinite in terms of the number of different possibilities, but we've converted it into something that only has 3 possibilities. It only has, 3 intervals, moderate, or what did they say, cool, whatever the middle one was, moderate, and hot, right? So we converted an infinite scale, we say, into a finite scale, into intervals, okay? And this process is usually called, has two names, typical names in data science. One is called discretizing. The other is called binning. So either word they use. So discretizing means making it into discrete intervals. That's the language. Making it into discrete means separate intervals. So they don't say separate, they say discrete. So making it into separate intervals or making it into discrete intervals is called discretizing. And the other word is, this is called a bin, the first bin, and this is called the second bin, and this is called the third bin. So this is called binning sometimes. So in either case, you can use either word or you'll see either word. It just means taking an infinite set, or it doesn't have to be infinite, but anyway, dividing it into intervals. Okay, so that's called discretizing or binning. Now, I assume that that's what was done here. I assume that this was probably recorded as numbers. And then they just made some interval boundaries, and then they could say whether something was hot, cold, or cool, or mild. Okay, and the same thing, I guess, with humidity. There's probably a numerical cutoff. If the humidity is above something, it's called high, another called that. And same thing with this. This, I don't know. Okay, now this, on the other hand, was probably never a number. This was a number probably initially, but I don't think this was ever a number, right? This is just, did they play golf or not? So that it probably didn't start out as any kind of number. It's just yes or no. So they didn't have to do anything special there. Okay, now, so as I said before, you can use any variable. If you're not working for a company and they don't tell you, what you have to do, then you could sort of use any variable as the output variable. Here at Play Golf is the output, but we could have tried to predict something else instead. Now, there's a kind of natural choice to make. Usually, this would be what you would try and predict, but who knows? You might be trying to predict this. But it's usually there's sort of an obvious choice as to which is the output variable or which should be the output variable. But it's not a hard and fast rule unless you're working at a company and they say, tell us whether somebody's going to buy this or not, or tell us what they're going to buy. That kind of thing. Then there's no choice, right? You're working for them. They already decided. So now, sometimes the thing that you're trying to predict is not a number. That's here. This is not a number. But suppose we were trying to predict temperature and we hadn't made it into bins. We hadn't made it into intervals. We were still looking at the numeric data. So instead of it looking like this, oops, where did it go? Instead of it looking like this was like 31, and this was 32, and this was 35, and this was 21, and this was 14, and this was 15, and this was 8, and this was whatever, 15, and so on, right? Suppose these were numbers. And suppose this was the variable we were trying to predict, not this one. Suppose this was the output variable, and all the others are the input variable. So suppose we were trying to predict that, and it's a number. It's not these categories here, not these bins. Okay, so the thing is, different algorithms work with numeric output variable, and other algorithms work for non-numeric output variable. So here right now, this is a non-numeric output variable. There are certain algorithms that would work for that or for this. If you're trying to predict this, there are certain, we saw that Weka has many, many, many algorithms. And some of them work for non-numeric output variables. And some of them don't. And some of them work for numeric output variables, and some of them don't work for numeric output variables. So you have to know, which algorithm. I mean, we will know. It's easy to know because once you load your data into Weka, for example, then, and once you tell Weka which is the output variable, and the word they use for the output variable, they don't use the word output. To me, it sounds natural to say output, but they don't use the word output. They use the word class variable. The class variable, that's the output variable. So in Weka, they call it the class variable. Now in RapidMiner, I forget what it's called. It might be called output. It might be called class, but I don't think it's called class. But anyway, in Weka, they call it the class variable. So once you load in the data that you have, and then you tell Weka which is the class variable, then what you'll see is when you look at the list of all the different algorithms that Weka has, some of them, maybe even a lot of them, will be grayed out. They won't really, they'll look semi-invisible or only semi-visible. So they won't be like, and you won't be able to run those. So Weka knows, or it tells you whether, it even makes sense to use a particular algorithm if the class variable is numeric. There's some algorithms that won't work with that. And if the class variable is not numeric or discrete or categorical, we also say non-numeric. Sometimes we use the word for we can say non-numeric. That makes sense. We can say another word is categorical. Another word is discrete, I guess. All those basically mean the same thing. So if the output variable is non-numeric or categorical or discrete, Weka will, and some of the algorithms won't work for that, and Weka will gray them out. So anyway, you need to be aware of this. So what do you need to be aware of? You need to be aware of which variable you're going to use to predict, which variable you're going to predict, which variable is going to be the class variable, which variable is going to be the output variable, all the same thing, and what to do if it's numeric. Now, what do I mean by what to do? Well, you could just use Weka's, the set of algorithms that Weka has that will work on numeric output data. So of course you could just do that, but I don't really want you to do that. The reason is because after we run the algorithms, we would like to know how accurate they are. Are they doing a good job or are they doing a lousy job? What's their error rate? And the way that you measure error is different, believe it or not. If you thought about it, you would understand that by yourself. But I'll just tell you that the way that you measure error is different if you have numeric data than if you have non-numeric data. The way that you measure the error. Now, we're going to learn the way to measure error for non-numeric categorical discrete data. We're going to learn that. We're not going to spend much time on what to do for numeric data. So, of course, you can if the algorithm can handle numeric data, then of course you can use it and you will get a measure of how good it is, but you won't have learned how to understand that from me. Or I don't know if we'll have time to do it. Maybe we will do it, but let's say you won't have learned how to understand the result from me. But if your output variable is categorical, non-numeric, discrete, then you will have learned how to measure that, I'm sorry, how to understand that report of how much error there was. We're going to talk about it. And because it's a little bit unusual and it's interesting to learn, and probably not, you wouldn't have thought of that so much yourself. So we're going to learn about it. So what does all this mean? So what this means is that what if your data set that you get here has a numeric output variable? What do you think I'm suggesting you should do? If your data has a numeric output variable. Now again, you sort of have a choice. You can decide what is your output variable. But let's just say you decide that the variable that you want to predict is, suppose that variable is numeric. But I'm not going to teach you about that, probably. So what do you think I'm suggesting you should do?
Professor, are you suggesting binning? I mean, discreting it using intervals?
Yeah, right. I'm suggesting that you should do what we did here. You should bin it. You should discretize it. Okay? Now, you can do that easily in Weka, and you can do that easily in RapidMiner. Or you could just, sort of figure it out yourself. You could just, I don't know, you could also do it in Excel using if-then. If the temperature is between blah, 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 then call it one thing. And if it's in blah, 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 then call it something else. So you could do that with if-then in Excel. But you can also, Weka has a way to do it quickly with a bunch of different sort of options. So it's just called, I think it's called discretizing. And you can set the number of intervals you want to break it up into. So you say, okay, I want to discretize it, but do I want to break it up into 3? Or do I want to break it up into 10 intervals? And do I want to break it up into, do all the intervals have to be the same size, same length, or not? So that's another option, right? Maybe you don't care. Maybe you don't care if they're all the same size. Maybe what you're more interested in is that when you're finished, you have the same, not that they are the same size, but that you have the same number of elements, the same number of people, the same number of rows in each of the intervals. So that means you need to juggle the size of the intervals to make sure that each one has the same number of elements in it. So anyway, there are these options that you can play with when you do discretizing in Weka. So you can use that. You can do that in Weka. But anyway, like I said, if the data is numeric, you should probably discretize it. Or what I should say is, part of your work should be to discretize it and use the algorithms that allow for that kind of data. And then if you want, you can also not discretize it, and that will give you different algorithms, and you can use those algorithms for that form of the data. So that would be a good thing to do, but at least you should discretize it and try out the algorithms that work for that, because I want you to try out what I'm going to teach you about how to measure whether your algorithm is doing well or not. And I'm going to teach you how to do that when it's a discrete output variable. So I'd like you to try that out and use that in your report. Use what we're going to learn in your report about how to measure it. It's called model evaluation. So I want to teach you model evaluation for categorical, discrete, non-numeric output variables. Okay, so we want to learn about that. So anyway, so some of the, so going back to the data, so some of that, you might naturally choose a numeric variable. I mean, it happens to be numeric, and that might be the natural choice for you for the output variable. Then you can just discretize that variable. You don't have to do that, but in our class, you have to do it. Typically, you could do it in any case, because that will allow you a different set of algorithms you can play with on that data. But you don't, anyway, for our class, you should do that. Okay, so let's keep going. So what if it's numeric? At least you should convert to non-numeric and make a new column that is non-numeric, and test your algorithm on that data. And then you can also, if you want to, take the original numeric and try that out as well. Now, what if let me just point out something that just came to my mind. Suppose you had some data. Let's suppose we were trying to predict the stock market from Microsoft stock. So we have, the price. Or let's not do that. That's not too good. Let's try and predict house price, house selling price. By the way, when you name a variable, it's usually not a good idea to have spaces in the name, because some software doesn't deal with that very well. So usually you want to say either like this, no space, or like this, house selling, and same thing here. But anyway, I'm not going to do that now. So suppose, you have a house here and it's sold for $500,000, and another house that's sold for $600,000, and another house that's sold for $400,000, whatever that is. That's probably okay. And then, you have the number of rooms, and you have the size of the house, and you have the distance from train station, and you have the city, you have number of swimming pools, number of pools, blah, blah, blah. You have a bunch of data. Okay. And then you say, okay, now I have all these input variables. Say, these are my input variables. And here's my output variable. Okay, so my output variable is numeric. Okay, now Professor Cluster said, I'm supposed to make this into discretize. So I'm going to use either Weka, I'm going to use Excel, I'm going to use RapidMiner, whatever. I'm going to do it. I'm going to make it discrete. So let's say this one is called middle, and this one is called high. And, I'm just making this up. And this one is also called middle, right? Whatever. So we have that. Okay, now, does everyone follow what I've said so far? Is there anybody who's confused on what I'm talking about? Okay, now let's see. I have number, size, distance, train. I have city. I have number of pools. Let's add in one more. What else? Anybody have another variable?
When it's built, Professor.
What is it?
When it was built. the house age.
Age, good.
Yes.
Age. Okay, all right, now, let me ask somebody. Let me call on somebody. Okay. Let me call on somebody. Okay, how about Kairu Nisa? Kairu Nisa. Kairu Nisa Ozan Ifada. Your mic is muted or not muted? I don't hear you. Okay, let me call on somebody else. Let me call on Wang. Wang?
Can you hear me?
Yeah, can you just speak a little louder or closer to your microphone or something? Or maybe my sound is too low. Let me just check. My sound looks low. Say that again. Hello, Wang?
Hello, can you hear me now?
Yeah. Okay. Now, let me ask you a question, Wang-san.
Okay.
How many input variables do you see?
How many person variable? For me, I think all of them are variable.
Now, input variables. No? Okay, it's all right. You don't have to, as long as you're here,
6.
you don't lose any points. Let me ask somebody else. Chen Bier.
Yes, Professor, can you hear me?
Yeah. How many input variables do you see?
I guess 6.
Okay, good. What are they?
New
Number of rooms?
Oh, sorry. Number of rooms,
Uh-huh.
size, and distance from twin city, number of pools, and age.
Right, exactly. So, okay, so I think everybody agrees that there are 6 input variables. And what's the, I'm sorry, let me ask you, just help me out here. What's the output variable in this data set? Chen-san.
Oh, it's still me. Okay. So the output is the house selling price.
Okay, good. Right. So the output is the house selling price. So we just decided that there are 6 input, those are the blue ones, and there's 1 output, that's the green one. Okay, good. But then I said, okay, let's transform this one into this one. So we'll call this house selling price bin. Okay, because I'm binning it. Okay, does everyone understand? I wanted to bin it. I wanted to make it categorical because of everything I've been talking about. I said we want to do that. Okay, so now what is the variable that I'm trying to predict? Let me ask somebody else. What is the variable that I'm trying to predict? How about this person? So
Can you hear me?
yes.
Yeah. Can you repeat the question again, Professor?
Okay, I don't like to repeat. I usually hope that people have been paying attention, but I'll do it this time. What is the output variable now?
House selling price bin.
Bin, right. Excellent. Okay, so let me even change the color to another color. Let's change it to this color. So now the output variable is how this orange one here. Okay, so my question is, I hope that everybody understands that the answer to the next question. I hope that it's obvious to everybody. But I think we need to say it anyway. And anyway, so now, would it be correct now to say that now I have, before I had 1, 2, 3, 4, 5, 6 input variables. Now, would it be correct to say I have 7 input variables?
Professor, can I answer?
Okay, go ahead.
Yeah, I think yes, we can say, because
No,
I think
no,
house
no.
selling price would be dynamic input.
No. Okay, so the answer is a firm no. Now why is that? Okay, now everybody needs to clearly understand this deeply. I mean, it should be obvious.
Professor, can I answer this?
Okay, I was going to give an answer, but okay, you give yours first.
Because we predict based on the house selling price instead. So basically, you cannot say like there's 7 variables.
Right. Okay, so this data is really exactly the same as this data. Well, it's not exactly the same, but it would be stupid to say I'm going to predict what this is using this. I mean, is that a machine learning task? Is that a machine learning task to say, given this, I'm going to predict what this is? Is that a machine learning task? Is that something we need to get a computer to do?
No.
No, it's right. It's obvious, right? We know the rule that goes from here to here. We don't need any machine learning. If you include something that has complete information about this as one of your prediction variables, that's redundant. That's not useful. I mean, if you knew this, you wouldn't need this. You wouldn't need to predict this, right? If you knew this, you'd have no need to predict these, right? Why would you need to predict, whether the house selling price is mid, high, or mid? If you knew the actual price, it's just stupid. You don't need it, right? There's no point in doing that. If you had this information, you already have your answer. Machine learning is when you're trying to extract information out of variables that, the reason I said everybody should understand this without me explaining is because I can't figure out how to explain it because it seems so obvious. But sometimes things are obvious, they're hard to explain. But you don't want to include something that is a direct. There's no way that if you had this information that you would not have this information. So there's no point in doing that. It's like, I can predict, here's another example. I can predict okay, whoops. I forgot. Okay. 8 p.m. Does anybody know what time the stock market closes? Does anybody know what time the stock market closes? Well, I don't know. I don't know.
Professor.
It kind of depends on which stock market. But I'm sure they're not open after 5 p.m. They close by 5 p.m. So if it's 8
I think
p.m.
it's around 4.
Okay,
Sorry.
depends.
Yeah.
Market.
I think it's around 4 p.m.
Okay, whatever. It's 4, it's 5, whatever it is. If it's 8 p.m., I can predict what the price was today, right? Does everyone agree with that? But the problem is using the word predict is sort of stupid in that case. Right? I shouldn't say predict when it's 8 p.m. because all I have to do is check, right? There's no prediction. It's already happened. I can just look at it. So there's no prediction happening. So, and there's no, it's cheating. I can predict with 100% accuracy. Every single day I can make the correct prediction. Here's what I wanted to, here's how I wanted to explain it. I can predict with 100% accuracy what the price of Microsoft is once it is 8 p.m. What the price, the closing price. Closing means what it was when the market closed. I can predict with 100% accuracy the closing price of Microsoft, what the closing price of Microsoft was today, once it's 8 p.m. Does everyone understand what I'm saying? Once it's 8 p.m., I can say, okay, I'll tell you what Microsoft is going to be today, the closing price. It almost doesn't make sense to speak that way, but because, and I can do it with 100% accuracy. But would you say that my algorithm is worthy of being upset? Can I say that my algorithm is perfect because it can take this kind of data and do this? Would you say it's fair for me to say I have 100% accuracy in my algorithm?
No.
Right? That's cheating to say, I can
No,
go to investors and say, okay, give me, $500 million because I have an algorithm that has 100% accuracy. So give me all this money because, and I'll give you my predictions. And, you want 100% accuracy. So give it to me, give me the money. You're going to get 100% accuracy. Is it fair for me to say that?
No.
No. Why not? It's a little hard to say why. Explain that. I don't know.
If answer it, Professor.
What? Yeah.
Okay. The prediction, it's not really a prediction. It's just we are looking at the number of after the stock market has closed for the day, and that's kind of cheating. So you can't really tell someone that, yeah, my prediction is 100% correct when you are predicting it after the market is closing. That's not really how it works.
Right. Okay. Right. So I hope everybody understands what I'm talking about. It doesn't make sense to say my algorithm is 100% accurate. Right? It's just a stupid thing, right? It's meaningless. So, what does this mean? Why am I bringing this up? Because in your data set, you're going to choose one of the variables to be the output variable. Then you're going to have a whole bunch of input variables. Remember, I also used the word, instead of output variable, I also used the word class variable. Output variable or class variable. So you're going to choose one of the variables to be your output or class variable, and the rest of the variables are going to be your input variables. Now you have to check are there variables in here which are like cheating? Just like before, we said, this is kind of cheating, right? I'm using, or going back to here, where was it? Going back to here. This is also cheating. If I use this to predict this, that's cheating. You know, it's the same information. But in your data set, I don't know, I can't guarantee that there aren't some situations like this. Or generally speaking, whether, you know, this is an issue in these particular data sets or not, I don't know, because I didn't check all the columns of all these data sets. But in general, you have to make sure that you're not doing this. You have to make sure that you're not doing this. You can't use the same information just coded basically in a different way to make predictions and then report the accuracy of your predictions as being high. It's cheating. And it doesn't, it's like you would never, you know, I would, you know, if I'm making predictions about Microsoft stock, I would never know the closing price. You know, that's not, you know, I want to predict what the price is going to be tomorrow, right? That's really what I really want to do. So I'm not going to know what the closing price is tomorrow, today. So it's cheating if I do that in my modeling and using an algorithm in my data science project. It's cheating to do that, come up with an accuracy, and then pronounce to everybody, that's the accuracy of my work. It's cheating, it's lying. So you can't do that. So I wish I had a more theoretical explanation of that, but I can't figure out how to say that. But I'll just say it's cheating or lying. So anyway, so you have to, when you look at your data, make sure that you don't have that situation, this situation. I don't know what they did in these data sets, you know, but you have to make sure that you're not using the same data just coded in a different way, as one of them as the input and the other as the output. Okay, you can't do that. It doesn't, you know, it's just stupid. Okay, so I won't go through that anymore. So now, what else? Think about which variables may have, oh, the next thing is, which variables have good information for predicting something and which may have zero information. So let's say I go back to here and I add in one more column here, and that is called transaction number. Okay. So I have another column there, and that's another input variable. Okay, so the transaction number. So this is transaction number, you know, 874, and this is transaction number 875, and this is transaction number 876, right? I think everybody knows what I mean by transaction number, right? It's just some kind of ID number. And they don't even have to, you know, they may not be even in order. Maybe this is like 1002 or something. Okay, so so you have to think about which variables have good information in terms of predicting either this or this way, depending on which way you code it, and which variables have no information. Now, basically, this has no information. The transaction number, especially if it's not recorded like according to a time, suppose this is set randomly. So it's not like this one happened before this one, or this one happened before this one. Suppose these numbers are just set up randomly. Then that has absolutely no predictive information in terms of this. So you don't really want to include that in your work. So if you have something that has zero predictive power in terms of predicting the house selling price, now this could have some power if this meant that this came before this and this came before this. If that's what these numbers meant, then maybe, you know, knowing that 874 was earlier than 876, maybe the housing market started to go up. And so maybe that is like time. Maybe that represents time, and time typically does have predictive value. When things happen, has some predictive power, right? If the housing market starts to go up, then you know, knowing at which time it occurred could be important, could help you in making predictions. But if these were just set randomly, they had nothing to do with reflecting the order in which these were sold. These are just random numbers, like random ID numbers or something, then that wouldn't help at all. Okay, so then you don't want to include this as an input variable in your study. So that's what I'm saying here. Think about which variables may have good information. Now, the problem here is that this has too much information about this. This has 100% information about this. But we said it doesn't make sense to include this as one of the inputs when predicting this, or vice versa. But this has zero, maybe has zero predictive power. In that case, you don't want to use that either. Okay? So we need to think about those things. You don't want to do nonsense in your, you know, when you're doing, when you're building a model, when you're trying to make these predictions, you don't want to do nonsense. So this would be, including this is useless. You want to get rid of that. And this is nonsense or cheating even to include this. Okay. So what else? Here. And also you're going to see sometimes in some of these data sets, they're going to have one file which is called test CSV and another file which is called train CSV. Now CSV just means like Excel file or something like that. It means comma separated value. I think we talked about it. So you're going to see that. But anyway, you're going to see test and train. So what they are doing is, let's go back to Weka for a minute. And it takes about a minute for Weka to open on my computer. Now, after you get your group assignment, the first thing you have to do is send email, because that's the only thing you'll have for each member of your group. Send email to each member of your group, giving them 2 forms of contact that you check every day so that they can contact you easily every day. And whenever a member contacts you, the rule is that you have to respond within 24 hours, hopefully less than 24 hours, but never more than 24 hours. So you have to give 2 forms of contact to send to each of the members of your group. Okay, let's just look at this. To explain this test and train. So let me find one of these data sets. So they are located, by the way. We have to go, I think, here. No, we have to go here. No, Let me do this. We have to go. Guess we go here. This PC. And then we have to go to C. And then we have to go to Program Files. And that's where WECA is. Program Files, and that's where WECA is. Then once you get to WECA, this is WECA 3-8.5. Once you get to WECA, you go to the data files. They give us some simple data sets to play around with. So here we have it, and here's the weather nominal. Now, nominal means it's another word for categorical or non-numeric. So we talked about those words for non-numeric, and nominal is another word for non-numeric. So we have weather numeric, but we also have weather nominal. So this has some, like in the temperature, it's the number. But here, as we saw, the temperature was not a number. So let's open this one again. Okay, so temperature, you can see the values are here, over here. They are hot, mild, and cold. By the way, when you put your mouse on the pictures and you let it sit there for a second, it shows you which category you're talking about. Hot, mild, and cold. So there's, you can see 4 instances out of this data set. There were only total number of instances, so total number of rows was only 14. And of those 14, 4 were hot. Of those 14, 6 were mild. Remember, hot, mild, and cool. And 4 were cool. So if we add those up, 4 plus 6 plus 4 is 14. The total number of rows or instances was 14. Anyway, what was I talking about? I was talking about, oh, train and test. Okay, so what do we mean? Well, we did this before, and what we did is to build a model in WECA, you have to go to this tab here, the classify tab. There are other tabs here, these other tabs here, but this is the one that you need. This is the one it opens up with, but you need to go to this one to do a model. So you click on that, and then here we saw that you can choose the classifier or the model, algorithm, or I'm sorry, not the model, I'm using the word model wrong. This is where you can choose the algorithm. It's also called the classifier. So I don't really, the model is slightly different usage. Anyway, but let's just call it a classifier or an algorithm. And last time we chose the tree, and it had a weird name. I'll try to explain that later, but right now I just wanted to show you. So this was the name of this so-called tree. And we did this before, and we just click start. And here, this is where you set which is the variable that's going to be your output variable. And it's automatically set to play, but you could change it. You could say, I want to predict the temperature, or I want to predict the humidity or the windy or whatever. But we don't. Actually, we want to predict play. So this is called the class variable, the one that you want to predict. And it's set at play, so I'll just leave it there because that's what I want. And then I click OK. And then we can see, we saw it wasn't so accurate. It was only 50-50. 50% were classified correctly, and then it made 7 mistakes also. 50% were wrong. So 7 were correct and 7 were wrong. And then we saw that if you right click on here, you can see a picture of this so-called tree. And we talked about how to read the tree. And we said like this, said, if the outlook variable is rainy, then it checks windy. And if windy is true, then it predicts they won't play golf. And you also built your own algorithms in your head, or using your head. And we used those. And they were actually, some of you came up with ones which were much better than what WECA just came up with. Much, much better. Somebody came up with a rule that was 100% accurate. Somebody else came up with something that was either 60 or 80% accurate. And that's better than this. This is only 50-50. So you saw that you can do a good job, but you can't do a good job if you had 1 million rows of data. And nobody can do a very good job in that case, I don't think. So, so we rely on machine learning in that case. But anyway, we have this. Now I'm going to ignore that. But going to here, we could have done this button here. Here we had a certain setting here, but here, this is more this is often what we do. What we've done here is what we do is we take 66 or 1/3 of the data only to build our model, to do the work of building this model. So we don't use 36% or sorry, 34% or approximately 1/3 of the data. We don't use it to build the model. Weka just, randomly selects 2/3 of the data and uses that. Like before, I had it said here, maybe Weka used all of the data to build this model. Actually, this is when Weka uses all of the data. Let's try that. We didn't do that. Whoa. Wow, how did that work? Oh, well, anyway, okay. Anyway, it got 100% this time. But using all of the data to build your model is a little bit like cheating. Usually what we want to do is say this. There's a different option here, but usually what you want to do is this. So what you want to do is you want to say, okay, I'm only going to use 2/3 of my data to build this model. And then what am I going to do? I'm going to take the rest of the data and one by one, I'm going to feed it into the model that Weka built with the 2/3 of the data. And I'm going to feed it in one by one from the 1/3 that was left over and put that in there and ask Weka, what do you think? Did they play golf or did they not play golf? So Weka is going to use that model that it just built to make its prediction. But the thing is, in our original data, we know, even for the ones that we're sending in now, we know whether they actually played or not, right? Because if we go back to all the data, we know for each, let's see, you can see the whole data set if you click, I think here, edit. So this is the whole data set. So for each row, I know if they actually played or not. Here they didn't play. They didn't play. Here they did play. They did play. They did play. So I know for each one of these. But what Weka is going to do when we click that 60, when we click that 2/3, 1/3 thing, is it's going to take 2/3 of these. So not all of these, like only this one and this one and this one and this one, and just 2/3 of the rows, and use that to build the model that it's going to build. And then with the ones that are left over, like say we didn't use this one to build the model, we're going to give it this and say, okay, Weka, suppose it was sunny, high, and true. What would you predict? And Weka is going to predict either yes or no. But we know in this particular case whether it was yes or no. So we can tell Weka you were right or you were wrong. And we can do that for for 1/3 of the rows. We can feed them in each row at a time of those 1/3 and say, okay, Weka, what do you think based on the model you built? Are they going to play or not? And Weka is going to say, well, I think in that case it's yes. And then you can check, oh, well, it was true. Okay, you got it right. Or it was not true and you got it wrong. So you can measure how many you got right. I'm sorry, how many Weka got right, or how many this tree got right and how many it got wrong. So let's try that. Did we do that? No, we haven't tried it yet. So let's try it. So suppose we randomly choose 2/3 to construct the model, and we use 1/3 to evaluate whether it, how well Weka is doing. So let's try that. Now it did terribly. Okay, so it only got from the, remember, we're talking about from the 1/3 that was left over. It got 2 of them right and 3 of them wrong. So not too good, right? It is not good at all. Only 40% of the time it got it right, and only 60% of the time it got it wrong. Now, let me say something else. You could say, well, suppose I randomly selected a different 2/3 to build my model, or for Reckitt to build a model, randomly chose a different set, because here it's randomly choosing 2/3, but I want to change to a different 2/3. You can do that in something called set seed, random seed it's called. So this is sort of like you just choose a different number here, any number, and it will randomly work off of this number and generate a different set of cases to build the model. So let me just put a different number in there and do it again and do this again. Maybe we'll get a different result. I don't know.
Professor, I'm
No,
sorry, but
I didn't get
your translation is cut off.
Thank you. Where is that translation? Where is it? So it did. Okay, is it on now? Let's see. Let me see something. Light stays on. Okay. Okay, now maybe it's working again. Thank you for letting me know. Okay. By the way, I'd like to ask if there are any, okay, if there are any, I need to know specifically if there are any Japanese language track students, any Japanese language track students that are here and that are using the translation service. So if if you're on the, some students at AP are on the English track and some are on the Japanese language track. Mostly it's Japanese students that are on the Japanese language track, but not always. There are also other students, non-Japanese students, that are on the Japanese language track. So if you are on the Japanese language track, and if you are using this translation software, is it still working? Yeah. I need a message from you. Glad I'm getting a new computer because this is slow. I need a message from you in the chat box stating about this. Say, I am on the Japanese language track, and you don't have to send it publicly. You can send it directly to me, but you need to send it to me saying, I am on the Japanese language track and I'm using the translation. I need to know that, how many students there are like that. So please send that. You can even send it right now. Okay, so going back to here, it didn't do well. And it did, even though I changed this setting here, here, let's see, I'll change it again. Let's see if it happens, if I get a better, okay, it turns out better. Let's see. So now it's better. Okay, so anyway, so it was a different, randomly it chose a different set for building the model, and the rest different set for testing the model. So that's what percentage split means. So we split the 14 rows of data that we have. We split the data set. Part of it goes into building the model, and part of it goes into testing the model. And we don't call it building the model. In this case, we call it training the model. So we train the model. We use certain of the data to train the model with some of the data. And then after we've trained the model or built the model, after the model has learned from that data, then we use the rest of the data, like the 40% or 33% we rest of data to test the model. So we have what's called the training data. That was 2/3 of the data in this case. And the testing data, that was 1/3 in this case. Now, we didn't have to use 2/3 and 1/3. I could have made this 80%. And I could see what happens now. Let's see what happens now. Now it got much worse, right? Look at that. Terrible. But anyway, we could, that just happened with this data and this algorithm and this split, this randomly split data. We could even make it 90%. That would mean you're using almost all the data for building the model. They call it training the model. And you're only using 10% of the data for testing. Didn't work at all. Okay, so now there's no real rule about what you should use here. Should you use 90? Should you use 80? Should you use 70? Should you use 60? There's no rule about what you should use. But you should have a good amount of data for testing. So if, let's suppose you had, 50 million rows of data, then using 90% for training, for building the model wouldn't be terrible, because 10% of 50 million is 5 million. You'd have 5 million rows for testing. That's a lot. So you don't have to worry in that case. You could use 90%. But anyway, there's no rule about it. And you can see that just by changing this, you can kind of cheat, right? You can report, oh, well, I used, what are you doing? I used a different random split. Oh, I can bring it up to much higher. Well, you can do that, but we're not supposed to do that, right? That's really not, we're trying to build something that's sort of going to work in the future, not just that we can report a high number, right? We want to build something which is useful. So, just sort of doing that is kind of not fair. Now, there are certain ways to sort of stop yourself from doing that. Like, for example, this, and we'll talk about what this does. But anyway, what I was saying is that in the data sets that you're going to get, sometimes it's broken up into training data and testing data. In that case, you have separate files. Now, you can use separate files in Weka, or you can put them all into one file. But if you want to use separate files, what you can do is you load the first, you load the training data in over here. So you'd open the training data over here. And then when you're going to do the building the model, you're over here. And what you do is you say, I want to use the training set. No, sorry. I want to use the supplied test set, a separate set for the testing data. And so then you just click here and select it. And you can select the separate data. So you can do that. You don't have to combine it. and then split it yourself, you can use the fact that it's already split for you by doing this. Okay. Okay, I never really spoke about all this clearly in past courses. I feel like I've said it clearly here. This is like, somehow I always thought that most of this people sort of knew, not all of it, not like exactly what I've been talking about here, but sort of that it was intuitive. But somehow, anyway, today, I kind of like what we've talked about. We've explained some things that are sort of, I don't know, logic errors that we could make that we don't want to make. Okay, so I will post this video on Manaba in case you want to review it. Now I will send out an Excel file that shows what group you're in and what your data set is. And I'll put that on Manaba, and everybody will get a notification about that. And then you have to right away check who's in your group, what their email is, and contact them ASAP. And I will give you an initial assignment on what to do with this data, and you have to start meeting with each other. Now, next week, we're going to talk about how to meet. But in any case, you should just establish a time and meet with each other on Zoom or online or something. Okay, you should have at least one meeting this week. Okay. All right. What time do we finish today?
It's 12:15, I think, Professor.
12:15. Okay, let me just go back to here and here and I want to go to here. And I want to go to here. And here. Okay, let's just watch a little bit of this. I don't think we have time to watch all of it, but and yeah, just watch it. And then we'll go into a little bit more about how to navigate RapidMiner so that this is easier for you to actually do it. But let's just take a quick look at this. We won't be able to watch all of it, but let's just take a little look at it. Okay. Let's see. Okay, let me share my screen. Okay, so now we're going to do a little. Now, as I said, we didn't really talk enough about how to work with RapidMiner for you to fully be comfortable with what I'm showing you here. But just for interest's sake, you might be interested in this, that's all. But one more thing, before we end, don't forget, the people who are on the Japanese language track, you must let me know today, before class is over. Must. Okay, let me share my screen. And let's just take a quick look at this, or a partial look at this. This is on YouTube, and I will share it with you. A bit of Twitter scraping, and then measuring the sentiment on tweets, or sentiment analysis of tweets. So I sort of did it already here, but I'll show you again. So let me disconnect what I have here. Now, here's a trick that you might want to use. If you don't want to delete operators, you can just select them and disable them. So I'll disable those, and I will select these two, which which I used before, and I'll enable them. So we're going to start out by searching Twitter, or using the search Twitter operator, and you just search Twitter here, and you drag it onto the screen and select it, and then we have to connect to Twitter. So what we have to do is make a connection to Twitter. So we go up here to connections, and we create a connection. So let's try that. Actually, I've already done it, but I'll do it again. So it shouldn't be a problem to do it again. So we can select here the type of connection, and we'll use a Twitter connection. The other options are like these, and there's Amazon and some others. Okay, but anyway, we're doing Twitter, and then we're going to have this connection in our local repository, and I already did one, but all right, let's call it Twitter connection 2, or maybe I'll call it 2021-2. Okay, and I'm going to click create. Okay, and then we need what's called an access token. And you need a Twitter account. I don't think you need a developer account, but you might. But I don't think you do. But you need a Twitter account. And the access token is sort of like an identifier that Twitter gives you, so that they know who's using the system, who's scraping the tweets, basically. And they can tell if you're doing too much or whatever. So, so here you click on here. And so you can click here, or you can click here, and we're going to need some code from Twitter. So I'll get that now. And after you've logged into Twitter, which I've already done, you will get this, and you just click here, and it gives you a code, and then you have to put that code in here. You put the code in here, and then you click complete. And then you've gotten the token from Twitter. And then you can test the connection here, make sure it's working, and then you can save it. Okay, and then we have to tell this search Twitter where our connection is, and you can see here's my local repository, and we have connections there, and the last one I made was here, so it's in the local repository, so we have to say that. So the choices are predefined or repository. So I guess there are predefined connections, but apparently they have been, or at least the Twitter one has been depreciated by RapidMiner. So you're not supposed to use that. In fact, I think you can't use it, doesn't work. But anyway, we didn't do that. We created our own up here. And and it's in the repository, and that's what we want to tell as the source. And the name is this one. I'll use the new one. And then you can search on keywords in Twitter. So let's say I want to search for tweets. Okay, suppose that I want to search on this Moto G9. So that's an Android phone, and recent or popular. And here, I think you're limited to 1,000 per day. I'm not quite sure about that. But right now, I'll just search for 10 tweets. And here, suppose I search for 10, and the last ID, each tweet has an ID, and the last ID is some number. Then I don't want to if I do another search, I don't want to get the same tweets again. So I can say since the last, I put in the ID number here of the last tweet, and then I won't get the previous tweets again if I run it again. There's a maximum ID, and there's a language. So I'm using English. There's a code here called ISO 639-1. If you look that up on the internet, you can probably find the codes for other languages as well. And I guess you can limit it and say until a certain date. Now you may not see all the parameters that I saw, so you'd have to click Show Advanced Parameters here. Now you can also, actually I don't know what the locale is, but filter by geolocation. If most tweets don't have a geolocation, they don't. I guess most users don't allow Twitter to know where they are, but some do. And here, if you choose that, you can give the latitude and longitude and radius and units and so on. Okay, so those are the parameters that we have to set here. Oh, we didn't mention this one, recent or popular. So you can choose recent ones or popular ones or recent or popular ones. Okay, so then we can connect this to an output. We can write it to a file. And we have to connect from here. We saw that before to here. And then we have to fill in these parameters. So we have to say the name of the file. So I'll call it Twitter example 2, as I just did this. And open it. And okay. Okay, I forgot one other thing here. Let's click back on here, and no, I'm sorry, that's all. Okay, and now this should work, and let's try it. Okay, it says it wants the latitude, but I don't know why. Oh, I clicked that. I didn't mean to click that. Okay, let's try it again. Okay, so now we get the result set, the tweets, and there are 10 of them here. And these are the IDs that I was talking about. So every tweet has an ID, so you can identify it with that ID. These are the dates. These are the users, the user ID, the language, and here's the text. That's kind of the most important part. You can see the geolocation. There were none of these allowed, I guess, Twitter to know their locations. And this is the retweet numbers, how many times they were retweeted. But let's look at some of the text. And let's see. Motorola Moto G unlocked. So maybe this is somebody trying to sell something. Check this out at Amazon. Motorola Moto G9 Play. Okay. So that was just a quick introduction. Now, I know that we're out of time, but there was one other point I needed to make, and that is about your data sets again. And I don't know how many people are still here, but anyway, Sometimes your data sets will come in two files, not the way I just described before, but where you have training and testing, but just you'll have two files. And I will post a set of videos. Actually, I think I might have already done it here, dealing with data here. I think it's here. And this tells you how you can merge. Sometimes the data comes in multiple files, not just one big CSV file, but multiple. And then you need to merge them. And you have to think about it. What does it mean? Well, how would you merge them? Anyway, there are various techniques here for how to do that. Some are with Excel, you can do it. You can do it maybe, I think, with RapidMiner. I think you can do it with Weka. But anyway, maybe doing it, there's several with Excel. I would think those would be the easy ones to do. And then if you have very large data sets, you don't need to use all of the data. You can sample the data. And there are some videos about how to do that using different tools like Weka, Excel, and RapidMiner. And that's also called class balancing in Weka. Okay, that's all for today. So you can check these videos when you need to deal with your data, especially if you have separate files or if you have too big data. And you'll get some homework this week, and you'll have to meet with your teams, and you'll get your data assignment and your team assignment. Okay, that's all for today.
Professor?
Yeah.
Professor.
What?
Thank you, Professor.
Okay, see you next week. See you in seminar.
Thank you, Professor.
One. Two. One, two. One, two. Is Nakatsuji here? Nakatsuji or Nishida?
Yes.
Okay, how about Nakatsuji? Okay, Nishida-san, Nishida? I got you. Okay, no problem. Okay, how about Hinata? No. Nishida, do you know who the student Nakatsuji is? Do you know that student?
Yeah, I know her.
Her. Is she taking this class?
Yeah.
Oh, there she is. Are you here? Oh, she left now. And how about, okay, so she's taking it, but she didn't answer me, right? Is she taking it? Is she Japanese track? Nishida, do you know if
Yeah.
is she Japanese track?
Yes.
Yes, she is.
Yeah.
So her name is Hinata Nakatsuji. And how about Shuji Ota? Are you here?
Yes, I am.
I think you're not Japanese track, right?
I just wanted to make sure.
Oh, are you Japanese track or not?
No, I'm not.
Okay, then I don't. I didn't need that.
Okay. Should I just leave then?
Yeah,
Okay. Thank you very much.
thank you. So can I ask you a question, Nishida-san? Nishida-san?
Yes,
I don't know. Can I ask you a question?
yes,
Are you using the translation?
yeah,
Is it working?
it's working.
Uh-huh. When you listen to today's lesson, approximately what percentage was clear? 100%, 90%, 80%?
About 80%, I think.
Okay, that's good. Okay. And okay, let me ask you a question. My idea for the group project was to put the Japanese language track students in the same group. Like everybody has to be in a group. So we're gonna have like, I don't know, maybe 10 groups or 15 groups. And my idea was to put the Japanese language students together in the same group. And then maybe it would be easy to communicate. And even when you write your paper, you can even write it in Japanese if you want. And then I can just translate it, some translation software. But I don't know, I don't know if you like that or don't like that. If that's not what you want, I won't do that. But that was my idea. But it's up to you and the other students, other Japanese language students.
That's better.
You think it's good?
Yeah.
Oh, okay, good. Okay, yeah, because I thought it would be interesting to see, how it works. And I thought it'd be more interesting if all the Japanese track students were in one group.
Okay. How many Japanese?
Well, right now,
Mm,
I only know about you and Yokomi Hinano.
mm.
But you also said Nakatsuji is also a Japanese language track student, right?
Okay.
So maybe it would be you and Yokomi-san and Nakatsuji-san as one team.
Okay.
So, okay, I just wanted to make sure that would be okay with you.
Oh, okay. Okay.
Okay, good.
Yeah.
All right, thank you so much.
Yeah. Thank you so much.
Okay, bye. Okay, Derek, thank you.
Bye.
for-
Bye. Thank you.
Welcome. Okay, Derek, thank you for helping today and letting me know that the translation wasn't working.
Yes, thank you, Professor. May I ask what was the purpose of the file you sent me? The attendance file?
I need to know who did you take attendance last week or not?
No, you told me that we were not gonna take attendance.
So we don't know who didn't come last week, right?
No, sir.
I wonder if there's any record of it on Zoom. There might be. Okay, never mind. Just skip that then. I thought you knew, but we didn't do that. I forgot. Okay, thank you very much.
So should I take attendance from now?
No, no.
Oh, okay, okay.
I just wanted, if I had known, it was just for something special I wanted to do, and it was just, I would have used that
I see.
today, but since I don't have it, I won't need it in the future now.
Okay.
Okay, thank you so much.
Okay, thank you, Professor. I'll see you next week.
Bye.
Bye.